What are the best ways to choose the origin for analyzing a system with torques and angular momentum? So we've been often referring to like values of R, whether we call them a moment arm or a radial distance, but we've always had to establish some point of reference for them, whether we called it a rotation axis or an origin. And usually we've been fairly intuitive about picking that, but in some problems it's not always obvious or clear what is the best choice. So I want to give some guidance for that by answering this question. And it says here, what are the best ways? Because none of the answers to these are really like absolutely set in stone, but I'm going to talk a little bit about like, well, what are some pitfalls? What are some issues if you make a different choice, and hopefully convince you that really these are the only like workable choices. There are three kind of categories of systems that we can look at and give answers for. One category is static systems. And it turns out for those types of systems, the answer to this question of what is the best choice is there is no best choice. Anywhere works. And the reason why is since there's no motion involved, there isn't really a reason that one point would be better than another. So you choose the one that is the most convenient. Now, the next two categories are going to be systems that are moving in some fashion. And when I say moving, that probably means if we're looking at rotational physics that they are rotating. A broad category, though, of type of rotation might be labeled as fixed rotation. In other words, this is a system that has some point around which it is forced to rotate. That's like a fixed point, right? An example of this that we encountered earlier on was a rocket car tethered to a particular point, either on the screen or maybe on the ground or on a floor or something like that. That point where the tether was affixed is a fixed point. And that fixed point, so I'm going to give the answer here saying the fixed point, or just fixed point. That's the one that makes the most sense. The issue is that if you choose a different point, whatever forces are exerted on the system at that stationary fixed point, those will apply torque to the system if you choose a different origin and will have to be accounted for. And in most all cases, that's going to be really inconvenient, maybe even impossible to actually do. So that makes any other option really not a good option. The third broader category is a free object. And we don't see this one too often. Most rotating systems that we've looked at fall into the fixed rotation. It's been pretty clear, like, okay, here's the point around this which this system is forced to rotate. One example, though, that we looked at that would fall into this category was the two rocket cars that were tethered to each other. We never said that any parts of that tether between the two rocket cars was actually like affixed to the ground in any way. So those two rocket cars just kind of orbited around each other, right? They just rotated around each other and they accelerated because there was a thrust force. How did we know that the rotation axis should be the point exactly between them? That's what we assumed that it was at the time, that it would make sense that we took the midpoint between those two objects. And it's maybe pretty obvious that that's what they would do, that they would rotate around that point. But again, we never forced them to. So I think it's in this category. And it turns out we made the correct assumption there because the general best choice for this is the center of mass point. And the reason why that's the best choice is if you choose another point, generally speaking, that other point would be a point that has acceleration. And that would mean that the perspective or the kind of the way you're looking at the system would be in an accelerated frame. If you're in an accelerated frame, there are pseudo forces, and those pseudo forces would apply pseudo torques at the center of mass point. That's really annoying, really inconvenient, maybe even impossible to deal with. So for a free object that is definitely moving, and you can have free objects, you know, a good example of this that I often imagine is like, what about like a boat, right? Maybe there's a propeller on a boat that is like applying some thrust to the boat, but is doing it in a way that is not just accelerating the boat linearly, but is also making the boat turn, perhaps. And usually those kinds of motions are a complicated combination of linear acceleration and angular acceleration. If you want to figure out what those things are for the angular acceleration part, you choose the origin for establishing torques, or basically the rotation axis, to be the center of mass point for the boat. So that's a pretty good example of where you might apply this. So that pretty much summarizes the answer here. Let's check out how it's stated in the slide. The slide gives you a nice table there. And so this is a good reference if you're ever doing a problem, because this is something that comes up once in a while where you're doing a problem and you might remember what you saw on a video perhaps, or in a class or wherever. And then you're faced with a problem yourself and you're stuck on this part about like, wait a minute, where am I gonna, like, what is R, right? And where am I going to measure that in reference to, and which is really equivalent to saying, what is the origin I'm going to be working with?